Hello everyone, my name is Vatori. In this video I will describe the API of the CW Arcade Smart Contract, explaining how it operates and its capabilities. Towards the end of this video I will demonstrate the dApp that uses the CV Arcade contract for a Web3 arcade machine. The primary purpose of this contract is to maintain a scoreboard for saving user scores and awarding the top player with a prize. This is the code that implements the smart contract logic. It comprises fundamental endpoints for a CosmWasm-based contract: instantiate, query, and execute. The majority of the methods are accompanied by unit tests, ensuring the smart contract functions accurately within the blockchain. For instance, this section of the test ensures that if the user wins the game and attains the top position on the scoreboard, they receive the entire prize pool, and the CV Arcade contract is left with a zero balance. It's time to deploy the code by constructing WASM files, storing the contract on the blockchain, and transmitting the instantiate message. Here we configure the administrator of the contract, who can add new users to the scoreboard, set the arcade name, determine the maximum scores available on the scoreboard, establish the coin denomination, and set the price, which is currently 0.25. akin to a quarter in traditional arcade machines. Thus, we have successfully deployed our smart contract. Let's explore its API. We can inquire about the balance, and in response we receive a list containing user information present in the scoreboard. It's currently empty. We will carry out multiple transactions to include some users. Let's inquire about the scoreboard state once more, and now we finally observe the scoreboard. For testing purposes, we will introduce a new user who will surpass all previous records and verify if it displays other user with lower scores. As we see, everything works as expected. Now I want to introduce you the play execution method. This method accepts the quarter transaction, and if it meets the requirement set by the contract, returns a successful response. This response serves as a signal for the dApp to permit the initiation of the game. If we transmit a lesser amount of coins than required, an error will be generated, effectively preventing the game from commencing on the dApp side. Additionally, there is a counter that signifies the total number of games played within the particular instance of CW Arcade. Let's execute the play execution method once more and verify whether the game counter has been updated. As observed, the counter has incremented by 1. Additionally, there is a method for updating the price, which could be prove useful due to inflation and varying admin transaction costs. Furthermore, a method exists that enables querying the current amount of coins in the prize pool. We'll perform a similar check by executing the play transaction and verifying if the prize pool has been updated. Whenever a user executes the play transaction by sending coins, this sum of money is distributed between the smart contract administrator for backend execution and the CV Arcade contract for the accumulation of the prize pool. It's time to observe the smart contract in action. Entering the username, pressing play, checking the transaction, 1 quarter, and the game should start. Verifying the current balance before establishing a new high score to further examine if you receive the reward. As observed, the scoreboard has been updated in conjunction with the dApp states, and our balance has increased by the amount of the prize pool. Splendid! These are the most significant features of the contract. I believe it has the potential to invigorate competitive games in the Web3 realm and inspire developers to deploy their games on the Cosmos-based blockchains. Thank you for your attention.